Hello YouTube students, my name is Vincent and today I want to take a look at the properties of logarithms. So let's go ahead and start by defining log base A of b equal to x and log base A of c equal to y. And I want to look at the property log base A of b plus log base A of c is equal to log base A of b times c. So we go ahead and we look at what we started with, and this allows us to say by using the definition of logarithms that a to the x equals b, using this log base A of b equal to x, and conversely using this log that we defined, we have a to the y equals c. So let's go ahead and take a look at, we have a to the x times a to the y. This is equal to, using the law of exponents, we have a to the x plus y. But keep in mind, a to the x is defined to equal b, and we have a to the y is defined to equal c. So this is all equal to b times c. Now I want to take a look at this statement here and this statement. We have a to the x plus y is equal to b times c. So now let's go ahead and take the log base a of both sides of this equation. So we have log base a of a to the x plus y, and we have log base a of b times c. Now, we need to take a look at this term here, this expression. And let's go ahead and consider this as a separate example. We're looking at z equals log base a of a to the x plus y. Now, using the definition of logs, we say that a to the z is equal to what's inside of this log term. So this is equal to a to the x plus y. Which, if we look a little bit closer, we have that the bases are the same, so now we know that z is equal to x plus y. So we could go ahead and evaluate log base a of a to the x plus y. This is simply equal to x plus y. Keep in mind, this is still all equal to log base a of b times c. But now let's go back to what we defined x and y to be. X is equal to log base a of b, and y is equal to log base a of c. So this gives us that log base a of b plus log base a of c is equal to log base a of b times c, which concludes the proof of this first log property. So now let's go ahead and take a look at the second log property. We have, let's set it up the same way, except this time instead of a to the x times a to the y, we want to look at a to the x divided by a to the y. And now using the law of exponents, we have that this is equal to a to the x minus y. Or simply, we look at a to the x is equal to b, a to the y is equal to c, so this is also b divided by c. So now we're going to follow this same strategy that we did over here. Let's take a look at these two terms together. We have a to the x minus y is equal to b divided by c. Let's go ahead and take the log base a of both sides. And now by the same reasoning as in this step here, notice how we have the log base a of a to the x minus y. This is going to simplify to just x minus y, similar to how log base a of a to the x plus y is simplified to x plus y. And now this is all equal to log base a of b divided by c. But now keep in mind, x was defined to be log base a of b, and y was defined to be log base a of c. So now we have that we have log base a of b minus log base a of c is equal to log base a of b divided by c, which proves this second log property. And now finally I want to look at the log property log base a of b to the n is equal to n times log base a of b. Now there's a few ways we could prove this one, but let's go ahead and use what we already proved in the first example. We want to keep that in mind as we start this. let's go ahead and take a look at log base A of b to the n. This is equal to log base A of b times b times b n times. So now what that allows us to do from what we just proved in this step here, we could go ahead and say that this is log base A of b plus log base A of b plus log base A of b. We could break this into a sum of n logs. So now we could go ahead and factor. We could factor out I'll go ahead and factor it off to the right. So we could factor out a log base A of b. And when we factor log base A of b from this term, we're left with 1. When we factor log base A of b from the second term, we're also left with 1. So we're left with 1 plus 1 plus 1 n times. So this is simply equal to n log base A of b, which tells us, since we started with log base A of b to the n, this implies that log base A of b to the n is equal to n times log base A of b. Okay, well, that's going to conclude the 3 proofs as well as this video. Thank you all for watching, and I hope it was helpful.